All right, everyone. So here we have a science news article about some new fossils, some dinosaur fossils, and it's pretty cool stuff. And if you look at this picture, this artist's rendition of the dinosaur in question, it's almost comical how big their necks are, how long their necks are relative to their bodies. It doesn't even seem possible, But I guess what you're not seeing here, or at least at an extreme angle, is their even longer tails that act as a counterbalance to this massive, massive neck. And the whole reason the dinosaurs would evolve a big neck like this is so that they can, without moving on their feet too much, they can swing their head around and cover a huge area. So they can graze vegetation off of the trees and bushes and stuff over this huge area, while their body itself stays relatively immobile. It's a way to consume a huge amount of vegetables, a huge amount of plant-based calories, while reducing your overall energy expenditure. And you end up, if that's your life strategy, if that's your evolutionary adaptation, that's your ecological niche, you end up with super crazy physiology, super crazy body forms like this. You see this a lot with all kinds of different dinosaurs, but it's probably the most stark and noticeable and almost absurd in some of these giant sauropods. But okay, so let's get into the article, and then we'll get into the science newspaper, or the science paper. New fossil analysis reveals dinosaur with the longest neck of any animal ever. With their long necks and formidable bodies, sauropod dinosaurs have captured people's imaginations since the first relatively complete fossils were discovered in the United States in the late 19th century. The original specimen that the Natural History Museum's Dippy was cast from was among these discoveries. Now, an international team led by Stony Brook University paleontologist Dr. Andrew J. Moore, and including Professor Paul Barrett, Merit researcher from the London's Natural History Museum, has reported that a late Jurassic Chinese sauropod, known as Mementosaurus sinocanidorum, sported a 15-meter long neck. So that's a neck that's about 45 to 50 feet long. That's enormous, longer than a car. The revelation comes as part of a paper that aims to document the diversity and evolutionary history of the family Mementosauridae, a group of particularly long-necked sauropod dinosaurs that roamed East Asia and possibly other parts of the world from the Middle Jurassic to the early Cretaceous. So it's a period approximately 174 to 114 million years ago. This name is hard to pronounce. Mementosaurus sinocanidorum was discovered in approximately 162 million-year-old rocks from the Xinjiang Uyghur Autonomous Region of northwest China in 1987 by the China-Canada Dinosaur Project Team, for which it was named. Sinocanidorum. At approximately 15.1 meters, its neck was more than 6 times longer than the necks of giraffes, and 1.5 times the length of a double-decker bus. This potentially makes it the longest neck of any animal to have ever existed. For sauropods, the long neck was one of the keys to achieving large body size. To power such a large body, sauropods had to be efficient at gathering food, and that's exactly what a long neck was built for. A sauropod could stand in one spot and graze the surrounding vegetation, conserving energy while taking in tons of food. Having a long neck probably also allowed sauropods to shed excess body heat by increasing their surface area, much like the ears of elephants. So the life cycle is basically what I was explaining earlier. The neck is like a giant, like the radius of a giant arm that can move in a big circular orientation to harvest all the vegetation in an area. But I didn't even think about the body heat angle of it, and that makes a lot of sense. You have this long, narrow, cylindrical appendage. Perhaps, as you saw in the picture up at the top here, perhaps there's like a thin frill along the bottom, which just provides more surface area. It increases the surface area to volume ratio, and that would make it, a really good structure for heat dissipation. And if you're talking about some of these tropical, really hot Mesozoic climates, heat dissipation is important. And that's really cool. I didn't even think about that. This lifestyle was exceptionally successful, with the sauropod lineage appearing early in dinosaur evolutionary history and persisting until the final days of the Mesozoic, when an asteroid wiped out most of the dinosaurs, except for the relatives of modern birds. So that's super, super interesting. This body form, this whole life strategy, this whole lifestyle of a big body size with a long neck grazing all this vegetation in an area, it's so successful for them that they existed and thrived and competed with other herbivores and competed against predators for several hundred million years. And the only thing that took them out was a giant multi-kilometer diameter rock from space that had to rewrite the entire surface of the planet. That's what it took to get rid of the sauropods. The question of which sauropod had the longest neck is not a simple one to answer. The largest sauropods tend to be some of the most poorly known, as it's very hard to completely bury such a large animal in sediment, the first stage required for fossilization. Poor preservation of these specimens and their closest relatives often makes estimates of their neck length speculative. Although Mementosaurus sinocanidorum is known only from a handful of bones from the neck and skull, the research team was able to reconstruct its evolutionary relationships and thus make comparisons to the unusually complete skeletons of its closest relatives. This allowed them to conclude that Mementosaurus sinocanidorum had a neck approximately 15.1 meters long, the longest of any known sauropod. Okay, so that's kind of an important detail, a clarification to make. They did not find a full skeleton of this particular sauropod. They did not find a full upper body or neck and skull of this sauropod. They found just a few bones of the neck and skull. But by comparing this to the full or more full skeletons of related species, close relatives, you can deduce growth patterns and growth rates and stuff between these different specimens, between these different lineages, and that allows you to infer with reasonable accuracy body sizes and like neck length and features, traits like that. So lead author Dr. Andrew Moore, Stony Brook University paleontologist, said, quote, "All sauropods were big, but jaw-droppingly long necks didn't evolve just once." Mementosaurids are important because they pushed the limits on how long a neck can be, and they were the first lineage of sauropods to do so. With a 15-meter-long neck, it looks like Mementosaurus sinocanidorum might be a record holder, at least until something larger is discovered. Unquote. That's super exciting. When it comes to dinosaurs, you always want to discover something bigger, something longer, something scarier, something more monstrous. That's like half the fun when it comes to paleontology and learning about dinosaurs, right? Anyway, the question of how sauropods managed to evolve such long necks and large bodies without collapsing under their own weight has puzzled scientists since their discovery. When studying Mementosaurus, the team were able to use computed tomography scanning to reveal that the vertebrae were lightweight and hollow, with air spaces comprising about 69 to 77% of their volume, similar to the lightly built skeletons of birds. However, such featherweight skeletons would also be more prone to injury. To combat this, Mementosaurus had 4-meter-long, rod-like neck ribs, bony extensions of the vertebra that created overlapping bundles of rods on either side of the neck. These bundles would have stiffened the neck of Mementosaurus sinocanidorum, increasing its stability, but also increasing its weight. The remaining mystery of Mementosaurus and many other long-necked sauropods is understanding just how they drew air down these long necks all the way to their lungs. Professor Paul Barrett, Merit Researcher of the Natural History Museum in London, explains, quote, "Like all other sauropod dinosaurs, Mementosaurus had a complex breathing apparatus that included not only the lungs, but also numerous balloon-like air sacs. These were connected to the lungs and windpipe, but spread throughout the interior of the animal's neck, chest, and abdomen." I did not know that. That is super cool. Taken in combination, these air sacs had a much greater volume than the lungs, and they even went inside the bones, hollowing them out. This extra space, that is incredible. I'm just having my mind blown right now. This extra space would have helped these gigantic sauropods to move the large volume of air in the lengthy windpipe that would have occupied their extraordinary necks. While Mementosaurus sinocanidorum is now thought to have the longest neck of any dinosaur, it was still not the biggest dinosaur. That title is held by a species in the titanosaur group, and dinosaur fans will get the chance to see the colossal titanosaur Patagotitan majorum, one of the largest known creatures to have ever walked our planet, this summer at London's Natural History Museum. And then there's a link to buy your tickets now. Okay, this is an awesome article. This is an awesome study. I just learned a ton of cool stuff. I think I'd read before that a lot of dinosaurs had hollow bones, and that this was a feature or a trait that was passed down to the birds. Like it was one of the things that helped them evolve into the flying niche, is that they had hollow bones and they were pretty lightweight. But the fact that they have like gas sacs. I mean, birds have gas sacs too, but I wasn't sure how those evolved. But here they're saying that dinosaurs also, like sauropods, had gas sacs all down their neck and in like their chest and perhaps the upper part of their abdomen. And so as they inhale, you have this suction force bringing air in, and it fills up the gas sacs. And perhaps that allows more air to, like, say all the gas sacs in the upper neck are filled with air and they inhale again. Well, the air is they can't fill these gas sacs even more, so the air is going to pull farther down, fill up more gas sacs. And then, you keep going and you keep doing this breath after breath, all the gas sacs are filled, and so then you can establish like a continuous current of air coming down into the torso through these gas sacs, even though an individual breath may not be able to pull, a single gulp or breath of air all the way down the full length of the neck. I don't know. I'm speculating. I didn't know half this stuff before, but still really cool. And then the fact that some of these gas sacs fill in the void spaces and the hollow bones. This is just mad awesome. Super cool. I love learning about dinosaurs and new fossil discoveries and stuff like this, because the insights it gives you to evolutionary history and the insights it gives you to like the origins of some modern day animals, like birds in this case. Birds were descended from theropods, not sauropods, but sauropods and theropods are related. They're both dinosaurs, so come on. It's all just super cool, really cool stuff. Love hearing about stories like this. So I did have the study open. Okay, so we can read the abstract. It includes basically a lot of stuff that was in the article, but okay. There's a bunch of acknowledgments here, so not the full text, so we'll just read the abstract. But, quote, the sauropod genus Mementosaurus from the late Jurassic, early Cretaceous of East Asia has a convoluted taxonomic history. Although included in the first cladistic analysis of sauropods, only recently has the monophyly of Mementosaurus and the anatomical diversity of the many penicontemporaneous East Asian eusauropods have been evaluated critically. Here, we redescribe the holotype and only specimen of M. sinocanidorum. Although the original diagnosis is no longer adequate, we identify several autapomorphies that support the validity of this species, including an elongate external mandibular fenestra and distinctive pneumatic structures on the cervical centra. We incorporate new data into a phylogenetic character matrix that also includes Bellosaurus and Danosaurus, both of which are known only from juvenile material and are often hypothesized to be neosauropods, or close relatives thereof. We recover all species of Mementosaurus as part of a radiation of predominantly Middle-Late Jurassic East Asian eusauropods, but the genus is non-monophyletic, underscoring the need for further systematic revision of Memencosaurid taxonomy. Analyses that score ontogenetically variable characters ambiguously recover Bellosaurus and Danosaurus as juvenile Memencosaurids, a hypothesis supported by several features that are unique to Memencosaurids or exhibit little homoplazy, including anteriorly bifurcate cervical ribs. Interesting. So if I'm understanding that correctly, what that means is that they've got cervical ribs, or ribs in the cervical region or the neck region, and by anterior bifurcation, I think I think what that means is that you have two points growing out of the cervical vertebra, and they fuse together, and then the whole rib structure comes down. And this is that anterior bifurcation. Alternatively, the ribs could grow up around the vertebra, in which case they would branch out at the tips, but I'm not sure. Just an interesting anatomical detail to take note of. Finally, computed tomography reveals extensive vertebral pneumaticity in M. cynocanidorum that is comparable to that of the largest sauropods, and updated scaling analyses imply a neck over 14 meters long, rivaling estimates for other exceptionally long-necked sauropods. Previous work has suggested that the elongated cervical ribs of particularly long-necked sauropods, such as M. cynocanidorum, stabilize the neck by limiting its mobility. Given that extent of pneumaticity responds dynamically to a bone's habitual loading, we propose that long cervical ribs and other structural modifications that limited flexibility promoted the evolution of increasingly long necks by producing a more predictable biomechanical milieu amenable to increased pneumatization. So in other words, basically what they're saying is that these cervical ribs that evolved to support the neck evolved as a result of the pneumatization of the neck bones, or I think that's the direction of the relationship. Maybe I'm misunderstanding this. But it seems to be that these two anatomical variables are related, and that if you have longer necks, you would need more rigid support structures to support the neck. But these would also allow for increased pneumatization of the bones, increased air sac volume in the bones. And perhaps as that increases, it reduces the weight of the neck and increases stability as well. So all these things are interacting. All these things, these variables are all interacting, and these evolutionary forces are tugging and pulling on each other to create these particular anatomical features, like this giant neck. So yeah, very cool stuff. Very, very interesting. I don't know about you, but I feel like I just learned a whole ton of cool stuff about dinosaurs. You gotta love it.